When integrating thermostats with boiler zone controls, understanding the voltage requirements and potential for interference is crucial. I will assume this air handling unit to be a packaged terminal air conditioner, which may or may not be the case. The packaged terminal air conditioner should have a terminal board with connections for a remote thermostat, even if it is a 24-volt unit. A generic relay is often considered, but in many cases, it is unnecessary. You can connect the thermostat directly to the zone output of the Taco SR506, and the thermostat will not interfere with the boiler's operation. The key here is to ensure the voltage of the thermostat matches the voltage of the zone output. This could be either 24 volts alternating current or 120 volts alternating current. Additionally, verify that the thermostat contacts are rated to handle the applied voltage and current. Using a thermostat with an incompatible voltage or insufficient contact rating can lead to equipment damage or failure. If the system involves a true packaged terminal air conditioner with mini-split-like remote controls, further investigation is needed. Identify whether the remote controls operate on 24 volts alternating current or low voltage direct current system. If the voltages are incompatible with the Taco zone output, a relay becomes necessary. The relay will serve to change the contacts to match the Taco zone output, ensuring a safe and functional connection. In summary, firstly, identify the voltage of the thermostat and the zone output. Secondly, verify the thermostat's contact rating. Thirdly, if dealing with a packaged terminal air conditioner with mini split-like controls, determine the control voltage and use a relay if necessary to match the Taco zone output. The Taco SR506 switching relay is a common control unit that manages zone circulator pumps based on thermostat calls for heat. The zone outputs on the SR506 are typically either 24 volts alternating current or 120 volts alternating current, depending on the model and configuration. These outputs energize the circulator pumps for each zone when the corresponding thermostat calls for heat. When connecting a thermostat to the SR506, it's imperative that the thermostat's voltage matches the zone output voltage. Connecting a 24 volts thermostat to a 120 volts output or vice versa will likely damage the thermostat or the SR506. Thermostats have contact ratings that specify the maximum voltage and current they can safely switch. Exceeding these ratings can cause the contacts to fail, potentially leading to a short circuit or fire hazard. Always consult the thermostat specifications to ensure it's suitable for the voltage and current of the zone output. A relay is an electromechanical switch that allows a low-power circuit to control a high-power circuit. In the context of thermostat and boiler control integration, a relay can be used to isolate different voltage systems and ensure compatibility. The relay's coil is energized by the thermostat signal, which then closes or opens the relay's contacts, completing the circuit to the boiler zone control. When using a relay, select one with a coil voltage that matches the thermostat's output and contact ratings that can handle the boiler's voltage and current requirements. For a packaged terminal air conditioner with many split-like controls, the remote controls often operate on low voltage direct current. In this case, a relay is essential to interface with the Taco SR506, which typically uses 24 volts alternating current or 120 volts alternating current zone outputs. The relay's coil would be connected to the low voltage direct current control signal, and its contacts would switch the 24 volts alternating current or 120 volts alternating current signal to the boiler zone control. This isolation prevents voltage conflicts and ensures proper operation. When connecting a thermostat directly to a Taco SR506 zone output, the wiring is relatively straightforward. The thermostat typically has two wires for heating, labeled R and W. The R wire connects to the 24 volts alternating current or 120 volts alternating current hot wire from the SR506 zone output, and the W wire connects to the SR506 zone output switch terminal, which activates the circulator pump when the thermostat calls for heat. Ensure the wires are securely connected and properly insulated to prevent shorts. When using a relay, the wiring is slightly more complex. The thermostat's R and W wires connect to the relay's coil terminals. The The Toka SR506 sun outputs 24 volts alternating current or 120 volts alternating current hot wire connects to one of the relay's common contacts, and the other common contact connects to the circulator pump. When the thermostat calls for heat, it energizes the relay's coil, closing the contacts and completing the circuit to the circulator pump. Before making any electrical connections, always turn off the power to the boiler and the thermostat circuit. Use a voltage tester to verify that the power is off before proceeding. Follow all applicable electrical codes and safety guidelines. If you are not comfortable working with electricity, consult a qualified electrician. Incorrect wiring can result in equipment damage, electrical shock, or fire. After completing the wiring, test the system to ensure it's functioning correctly. Turn on the power and set the thermostat to call for heat. Verify that the circulator pump activates and that heat is being delivered to the zone. If the system does not operate as expected, double-check the wiring and voltage connections. Troubleshooting electrical systems requires a systematic approach. Firstly, verify that the power is on and that the thermostat is set correctly. Secondly, check the wiring connections to ensure they are secure and properly insulated. Thirdly, use a voltage tester to check for voltage at various points in the circuit. If there is no voltage, trace the circuit back to the power source to identify the break. If there is voltage, check the components in the circuit, such as the thermostat, relay, and circulator pump, to see if they are functioning correctly. Replacing a thermostat is a relatively simple task. Firstly, turn off the power to the thermostat circuit. Secondly, remove the old thermostat from the wall and disconnect the wires. Thirdly, connect the wires to the new thermostat, matching the wire labels to the thermostat terminals. Fourthly, mount the new thermostat on the wall and turn on the power. Programming a thermostat involves setting the desired temperature and schedule. Most thermostats have a programming mode that allows you to set different temperatures for different times of the day. Consult the thermostat's manual for specific programming instructions. Some thermostats also have features such as adaptive learning, which adjusts the heating and cooling schedule based on your preferences. Energy-efficient thermostat settings can save you money on your heating and cooling bills. A general guideline is to set the thermostat back several degrees when you are away from home or asleep. You can also use a programmable thermostat to automate these temperature changes. In the winter, set the thermostat to 68 degrees Fahrenheit or 20 degrees Celsius when you're home and lower it to 62 degrees Fahrenheit or 17 degrees Celsius when you are away or asleep. In the summer, set the thermostat to 78 degrees Fahrenheit or 26 degrees Celsius when you are home and raise it to 82 degrees Fahrenheit or 28 degrees Celsius when you are away. Regular maintenance can extend the life of your thermostat and ensure it's functioning correctly. Clean the thermostat regularly with a soft cloth to remove dust and debris. Check the wiring connections to ensure they are secure. Replace the batteries in the thermostat as needed. If you notice any problems with your thermostat, such as inaccurate temperature readings or erratic behavior, consult a qualified HVAC technician. Understanding the basics of thermostat and boiler control integration can help you troubleshoot common problems and ensure your heating system is operating efficiently and safely. Always prioritize safety when working with electrical systems, and consult a qualified professional if you have any doubts or concerns. Remember to consult the manufacturer's documentation for specific instructions and safety guidelines.